Hello guys, welcome to Dan's IT Network. And for today's video, we'll talk about RSTP. Okay, so RSTP, this stands for Rapid Spanning Tree Protocol, right? It's the evolution of STP, okay, which is the classic one, and it is the modified version, okay, the RSTP. And RSTP is standard series is IEEE. It's the 802.1W. Okay, it's an open standard protocol, and this was published in 2001. Okay, and unlike in the STP, the classic one, it has a slow convergence, while in RSTP it has a rapid convergence. Okay, it's a much more faster compared to the classic STP. Okay, well, if you do not have a basic understanding about STP or the classic one, well, um, I do suggest you to watch my video tutorial about STP, well, just basic understanding for you to understand this better, the RSTP. Okay, and I will post the link on the description below for you to watch and learn. All right. Okay, so let's proceed. So the port roles in the RSTP, we have five. All right. Number one is the root port. So this is the RP, so root port, and this root port are closest port to contact the root bridge. Okay, and number two, the designated port. All right, so these are the forwarding ports. All right, on the rapid spanning tree protocol, and they are active. Okay, number three, the alternate port or the AP. Okay, the job of this alternate port, let's say if the root port goes down, all right, or went down, then the alternate port will take place. Okay, all right, and then next, number four for backup port or the BP. Okay, so the job of this backup port is if the designated port went down, all right, or goes down, then the backup port will take place. All right, and last is the disabled port. Well, we will not gonna tackle more about this. It's because it's administratively disabled, and anyway, it's not running STP messages. Okay, and the port states in RSTP, we only have three. Okay, unlike in the STP is that we have five. So we have the disable, listening, blocking, learning, and forwarding. Okay, well in RSTP, okay, they combine the learning. I'm sorry, the listening, disable, and the blocking into just one, which is discarding. Okay, and the this discarding is it can receive STP messages. When I say STP messages, these are the BPDU. Okay, so BPDU stands for Bridge Protocol Data Unit, and this BPDU is a message being sent every 2 seconds. Okay, and it is being exchanged, okay, or exchanging between the switches participating in the spanning tree protocol or operation. Okay, so discarding again, this can um, this can receive spanning tree messages, but it cannot send STP messages or the BPDU. It cannot learn about MAC addresses, and it cannot forward data packets. In learning mode, this can send and receive BPDUs or the STP messages. It can also learn about MAC address. However, it cannot forward any data packets. But in number three, the forwarding, this can send and receive STP messages, the PPDU, and it can learn about MAC addresses, and it can definitely forward data packets. All right. So, how does the STP working on a network? All right. So here is the network. All right. So we do have here a four switches. So switch one, switch two, switch three, and switch four. Okay. Well, they are actually talking to each other using the STP messages or the BPDU. They're actually trying to elect which one of them should be the root bridge. Okay, when we say it's the root bridge, then STP will try to look for the lowest bridge ID among them. All right, so bridge ID priority number. But we do know that every switches, they do have a default bridge ID priority number of 32768. Okay, and then since all of the switches are in the default VLAN, which is VLAN 1, so we will add the default priority number 32768 plus 1, so it will become a 32769. So all of them will be having a 32769 bridge ID priority number. So if that's the case, then STP cannot elect which one of them should be the root bridge, because all of them have, they have equal bridge ID priority number. Then the second thing that RSTP will do is it will try to look for the lowest MAC address. All right, and I already labeled that the switch one has the lowest MAC address though, so that's why this is the root bridge. Okay, all right, and let's take a peek though. All right, so let me move this. Okay, let me open this switch one. All right, okay, let me spread this, and I'll hit enter to get started. I'll type here enable, and let me type here show spanning dash tree. Okay, so as you can see here, well, if it's the root bridge, definitely then it should have, all ports should be on the forwarding state. Okay, and as we can see here, all right, all ports are on the forwarding state. So role, they are all designated port, and they are all forwarding, and the cost is 19. Okay, since they are on the fast ethernet port, so this is fast ethernet and fast ethernet, then the cost of the fast ethernet is a 19, so that's a port cost. All right, so port path cost, if it's a fast ethernet, it should be the 100 megabit per second. It's a port path cost is a 19. Okay, and if it is a, gigabit port, all right, which is here, the port path cost or the port cost is 4. Okay, so the smaller the fastest, and the smaller the better. Okay, all right, so again, this is the root bridge, and we can tell that this is the root bridge. It's because by looking on the information in here, the root ID and the bridge ID is they have the same MAC address. Okay, you see, and also it shows in here that this bridge is the root. All right, and this message in here says hello time 2 seconds, so this is the BPDU. So BPDU is, they're sending hello packets every 2 seconds on the network. Okay, on the STP. All right, so again, they are all forwarding, and the SW1 is the root bridge. And one important thing that you also need to know about here is it shows in here is spanning tree enabled protocol, so we're using the RSTP. Okay, all right, well, why it is RSTP? It's because I'll try to look in here. So privilege mode, I'll type here show run. Okay, and you'll be able to see in here, scroll up, that by default, all right, the spanning tree mode rapid PVST is enable on the switch. Okay, well, let's say if on your case is if it's not enabled, then what you can do is you can go to the global config mode by typing the comp t comp t, all right, and then type here spanning tree, and then space mode, then space question mark, then all you have to do is to type the rapid PVST. Okay, all right, so I'll type it since it's already running, and let me type it just for you to see. Okay, and that's it, and control C, and then let me save the configuration. All right, and then I'll close this, and let's keep looking. All right, so let me open this switch number 3, and let me spread this command line interface, and then hit enter to get started. Then I'll type here enable, and then I'll type here show spanning dash tree. Okay, And as you can see here, that this is the VLAN one, so we are on the default VLAN, and spanning tree enable. The RSTP is enabled. Okay, well, it just shows in here RSTP. It's not rapid PVST. Well, it is because we did not create any additional VLAN though, so we are only using just the default VLAN. That is why it's RSTP. Okay, all right. So in here is it gives us the information about the root bridge. Okay, we do know that the root bridge is the SW1, so this is its MAC address. All right, so MAC address, and the cause is 19, and the priority number is 32769. Again, is as I mentioned a while ago, every switch has a priority number or bridge ID number of 32768, and then plus the VLAN extension ID, which is number one, so it will become 32769. Okay, so that is why um, this root bridge has a bridge priority number ID of 32769, and cost is 19. Why it is 19? All right. Well, for this SW3 to reach this S1, okay, so the port cost is 19 since they are connected, on a fast Ethernet though. So that is why it is showing in here that it is the port path cost is 19. Okay, to reach the SW1 on this fast Ethernet. Okay, all right. And this bridge ID, this is the information or the MAC address on the switch 3. Okay, and priority number, they have the same 32769. And by looking on the status on the port on this switch number 3, okay, this F0/1, it shows in here that this is the alternate port. Okay, and it is blocking. All right, and the cost is 19 since it's a fast Ethernet. All right, and the fast Ethernet 0/2, this is the root port. Okay, it is forwarding, and the cost is port path cost is 19. All right, and the priority number in here is a 128.2. All right, so if you try to compare this priority number to this interface port, okay, it's the same as the number 2 in here, and then number 2 on the port ID. All right, and then on the gigabit 0/1, which is here, okay, so the RSTP made this as the designated port, and it's forwarding, and the port cost is 4. Okay, so it's because it's on a gigabit port, it's 1 gig. Okay, so 1 gig is equals to 4. Okay, for the port cost or port path cost, and then the priority number is 128.25. All right. Okay, so as you can see here, all right, so this the job of this F0/1, let's say if the link goes down on this F0/2, and then the F0/1 will take responsibility. So this will become then the root port if the F0/2 goes down. Okay, and then other thing that you might also wanted to ask, all right, so how come that the STP or the RSTP decide that the F0/1 is the alternate port instead of the F0/2? Okay, well, good question, because in RSTP there is a election that is or election process that is happening in here. Okay, so this switch 3 will actually base it's the bridge priority number to the switch 1, and we do know that this switch 1 has a bridge priority number of 32769, so they have the same though. But if they if let's say if this port is connected to another switch, then the lowest bridge ID priority number will win. Okay, but since they have they are connected to the same switch, and the priority bridge ID number is the same, 32769, so it's a tiebreaker. Okay, and next thing that will happen is um, on the neighbor switch, okay, since this SW3 is connected to this SW1 as the neighbor switch, it will try to look for the lowest MAC address on the neighbor switch. Okay, but we do know that they are connected again on the one switch is it has only just one MAC address on this SW1, so again it's a tiebreaker again. All right, and then the next thing that the RSTP will do is it will compare their priority number port ID. So whichever the lowest one, it should win. Okay. So by looking in here, right? Let me close this and let me go to the switch W1. Let's try to type this command show spanning tree. Okay. Let me spread this, and I'll hit enter to run this command. So as you can see here, okay, so we are on the SW1, all right? So this F0/1 is, you know, connected to this, F0/2 on this, switch, okay? And we'll take a look on the priority number, all right? This is the, for the F0/2 is 128.2, okay? So this is 128.2, and this F0/1 is 128.1. So this F0/1 has the lowest priority number on the port ID. So what happened is this of port 0/2 win because this has the lowest one. So that is why this F0/2 became the root port. All right, and the F0/1 in here became the alternate port. Okay, so that's what happened. That is the election process. Okay, and then let's keep looking. Let me adjust this network design over here because we're about to open this switch 4. Okay, and let me spread this command line interface, and I'll hit enter. I'll type here enable, and then I'll type the same command show spanning dash tree. Okay, and let's take a look. So we're getting the same information. So it gives us the information about the bridge ID, which is, its MAC address over here and priority number, and spanning tree RSTP is enabled. Okay, and this bridge ID, this is the MAC address of the switch 4. Okay, and by looking on the status on the port, the this F0/1 in here, okay, this is alternate port, and it's blocking. All right, as you see, it's color orange, and on this gigabit 0/2, it says that this is the root port. Okay, all right, so in here, so how come that the RSTP, okay, let me try to minimize this first. Okay, so how come the RSTP decide that this gigabit 0/2 is the root port, and then make this 0/1 as the alternate port? All right, that is a good question. Okay, well, it is because in RSTP there is another election that is happening in here. Okay, so whichever has the lowest port path cost will win. Okay, so by looking in here for switch W4, if to reach the switch W1, so the port cost in here is 4, right? So 4 plus 19. Okay, so that is 19, 20, 21, 22, 23. So that's a total of 23. All right. So versus on this path. So let's compute. So this is a fast Ethernet. Anyway, this is a hub though. It doesn't really, respond to STP. So this is a total of port path cost is 19, and then another 19 in here. So that is 19 plus 19. That is a lot. All right. So definitely that the port path cost will win over here. So that is why this gigabit 0/2 became the root port, and then this F0/1 became the alternate port. All right. So what will happen then here is if the fast Ethernet 0/1, right? Since that's the alternate blocking port, if the gigabit 0/2 route goes down or went down, then the fast Ethernet 0/1 will take responsibility. Okay. All right. And then next, let's go to the switch number 2, and I'll hit enter to get started. I'll type here enable, and then COM-T. I'm sorry. So we do not need to go to the COM-T though. We just want to view the. I'll type here show spanning. I'm sorry for that. So spanning tree. Okay, and let me spread this now. So this time in here on this switch, all right. So we have here a hub, but we just need to ignore this hub, okay? Because it does not really respond with the STP, all right. And the the purpose that I put this hub is because to show you of how is the um, backup port is working. Okay, So as you've seen here, on the SW2, so we have three ports. Okay, so this is the F0 slash 1, F0 slash 3, and F0 slash 2. Okay, so the F0 slash 1, it says in here that this is the root port. All right, so this is the root port. It is because it's closest to the root bridge. All right, okay, all right, so and F0 slash 2, right, what's the status? It is a designated port and it's forwarding and the cost is 19. Okay, so the RSTP decide this F0 slash 2 should be the designated port. And then the F0 slash 3, as RSTP decide that this should be the backup port, all right, or the blocking port, so backup. So what will happen here is if in case that this F0 slash 2 went down or goes down, then the F0 slash 3 will take responsibility. Okay. All right. And then now let's discuss more about, the election process. So how come that the RSTP choose this F0 slash 2 as the what do you call this, the designated port, okay, instead of the F0 slash 3. All right, well, there is another election that is happening in here, okay, and definitely it will base on the neighbor switch. All right, so the neighbor switch on this switch 2 is the switch 4 because they're connected to each other, okay, which is with this port. All right, so what will happen is the SW2 will try to look for the neighbor switch, which is SW4, for the lowest bridge ID priority number. But they are just connected into just one. All right. So definitely, if that is the case, then they do have the same bridge priority number, which is 32769. So it's a tie. All right. Nobody wins. Okay. And then the next election process then is it will try to look for the lowest MAC address. But since they are connected on just one switch, and it has the same MAC address, because it has only one MAC address then, and again though it's a tiebreaker, nobody wins. Okay, and then the next one, it will also try to compare the port ID. All right. Well, it will try to open this switch 4 in here. Okay. And as you can see in here that the F0 slash 1, which is over here, it's on the 128.1. And they are both connected to just one port. So nobody wins again. It's a tiebreaker. All right. And the next thing that will happen in here is the switch to then will just decide in here whatever the lowest port ID priority number. Okay, so let me open the switch to. So this is the F0 slash 3, right? And this is the F0 slash 2. So it will try to compare their priority number here. Okay, so 128.2 on the 0 slash 2 and 128.3. So the lowest one is the relying on the fast Ethernet 0 slash 2. So the fast Ethernet 0 slash 2 has the lowest priority number. So this one win. So this became the designated port, and the F0 slash 3 became the backup port. All right. And that's it. That's how rapid spanning tree works. All right. And at first though, it's just hard to understand, but if you try to replay the video and do it again, watch it, and you will be able to understand. Just keep on practicing. All right. And the next thing that we need to do, all right, so how about like let's say for example, okay, so I want this switch to be the root bridge instead of this. Okay, well, what we can do here on this switch number 2 is we can lower down the priority number, same as what we did on my video tutorial in STP. We lower down the priority number. Okay, or we can just make it as the root primary, okay, on this switch 2. So let's make this as the root ID then. Okay, so let's go to the switch. Okay, and then I'll type here COMT to go to the global config mode, and then I'll type here spanning tree. I'm sorry, there should be a dash. All right. Okay, and then space question mark. So I'll type here VLAN space 1, since we are on a default VLAN. Okay, which which is just VLAN number one, and then space question mark. So this time is we will be using then uh, the root. Okay, so before my video tutorial, we did use the priority, but this time we'll use the root. Okay, so I'll type here root. Okay, and then space question mark, and then I'll make this as the primary. Okay, so I'll type here primary, so that this switch number two then will become the root bridge. Okay, and then I'll execute this command by hitting enter on the keyboard, Control C, and I'll save the configuration, and I'll close this. And let's see though if this is now already the um, root bridge. Okay, all right, so let me try to fast forward the time. So here, okay, and then I'll open up this switch then. All right, and then I'll type here show spanning tree. Okay, all right, and as you can see here though, that's if it is the root bridge, okay, should have ports should be all forwarding. Okay, and as you see, they are all forwarding. Okay, and as you can see here, the let me spread this a little bit. Okay, so the MAC address on the root ID is the same as on the bridge ID, so definitely that this is the root bridge now. Okay, and it also tells us that on the root ID that this bridge is the root. Okay, and there you go. Well, you can try to play around with the network. Okay, well, if you want this switch to be the root bridge, then you can try to lower down the priority number, or if you want this switch then to be the root bridge, then you can also try the same command, which is the root and then primary. If you like this video, please do subscribe to my YouTube channel, Dance IT Network, to get more updates about Cisco CCNA. And if you have any questions, suggestions, or requesting for any video tutorial, then you can email me, danceitnetwork@gmail.com. Thanks for watching. Bye.